Good afternoon, everybody, and welcome to the Baker Institute Behind the Discoveries. I'm Matthew Keenan, and I get to be your host this afternoon for Unexplained Cardiac Death. In the spirit of reconciliation, the Baker Institute acknowledges the traditional custodians of country throughout Australia and their connection to land, sea, and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islanders people today. Matthew Keenan is my name, as I mentioned at the start, and I get to be the host today. I'm also an ambassador for the Baker Institute. Some of you might know me as a commentator on the Tour de France, but I come to this event with quite a bit of self-interest as unexplained cardiac death. Within my family, on my mother's side, my grandfather and two uncles all died of heart attacks before the age of 50. And as we will discover, as we hear from Dr Liz Paratz throughout this session, unexplained cardiac death, particularly for people under the age of 50, there are huge numbers, sadly, that cause death there. So I've got a fair bit of skin in the game in that regard. So I'm looking forward to hearing what Liz has to say. Some housekeeping first up. This session is being recorded, but the good news is all of your microphones are muted throughout the duration of the session. If you'd like to pop up any questions throughout, there is a Q&A button which is located in the bottom right-hand corner of the screen. If you're having any technical issues, there's also a chat button, and one of the people from the Baker will be able to actually respond to that and hopefully get you sorted out to be able to resolve that issue. We also wouldn't be able to host a session like this without the great support of many of the sponsors of the Baker Institute. On this occasion, we'd like to thank the Bank of Melbourne for their support, not just of this Behind the Discovery session, but also of their support for the Baker Institute. As many of you know, research is so important to getting better outcomes for everybody. Today's topic is cardiovascular disease, which is a major cause of premature death in Australia, and unexplained cardiac death, also sudden cardiac arrest and sudden cardiac death, is one of the biggest killers of Australians under 50 and is 5 times more likely to affect men. So I'm certainly interested in hearing what Liz has to say. Many of the young people affected by unexplained cardiac death are regarded as being fit and healthy, and we have little information as to why this happens. And that's why we've got Liz on board, who is a sports cardiologist at the Baker Institute and part of the team working on Australia's first sudden cardiac death registry. Liz, I'm looking forward to hearing what you've got to say about this incredible topic that doesn't get a lot of mainstream coverage, certainly not the sort of coverage that it does deserve. Firstly, thanks for joining us.
Thank you very much, Matt.
So, what is unexplained cardiac death? Because when I think of cardiac issues, the only thing that I think of is heart attack.
Yeah, and so I think there's a lot of overlap in people's understanding, and unfortunately there's often a lot of confusion. So it's a really good, I think, opening question to establish what's a heart attack, what's a cardiac arrest, what's a cardiac death, and maybe what's heart failure as well. So to start with my research, which is about cardiac arrest and cardiac death, cardiac arrest is when the heart stops, and it stops. And unfortunately, 90% of cases, that arrest ends in a death. The person's unable to be resuscitated. So there's very few conditions elsewhere in medicine that have a 90% death rate, which is why we think this is such an important area to be researching and improving outcomes in. And the heart can stop or arrest for a lot of reasons. And that's where all those other things feed in. So the heart can stop because you've had a heart attack. And a heart attack is when the arteries in your heart have got a blockage in. So when you hear, say, an uncle say they had a 90% blockage and had a stent, they may have had a heart attack, but they hopefully didn't have a cardiac arrest where the heart stopped. So if we were to draw a bit of a diagram, you can have a cardiac arrest that is or is not due to a heart attack. You can also have a heart attack that may have a cardiac arrest associated with it, or you might have the kind of heart attack where you get to go home the next day and your only complaint was the food you got in hospital. There's a whole spectrum kind of severity.
That one's a good outcome.
Yeah, yeah.
So this was a question, we've also had some questions come in beforehand. Jennifer asked this question about the difference between heart failure and heart attack, which you've just explained. And often there is just that conception that it is, you've had a heart attack, and a lot of that is related to actually your lifestyle choices, which is what you're doing a fair bit of research into. Is often it's not a lifestyle choice and you're trying to work out why.
Yes, that's exactly right. And the group who it often is less related to lifestyle in are our younger patients, with kind of this cutoff of, let's say, 50 years old. So if you're over 50, you are more likely to have what we call modifiable risk factors. So high cholesterol, high blood pressure, you may have diabetes, you might have a smoking history. But when we see heart attacks in young people, it's increasingly common that we see them in people who have 0 of those things we would consider traditional risk factors. And so that's one of the really interesting things in our registry. We look at young people who have no traditional risk factors, and we're trying to find what the risk factors are that we clearly don't know about. And probably a lot of those are genetic. And so we're trying to explain, I guess, the unexplained in that sense.
So how are you going about gathering that? Because we had another question that came in from Uma, which I thought was a really interesting question. And it's, how is the cause of death established at autopsy?
Yeah, so we've got a really, I think, neat registry design that's one of the most comprehensive in the world when we compared it to other registries. And what we do is we draw on multiple existing data sources in Victoria, where we're very lucky to have excellent record keeping and data collection. So the first place we identify people who've had a cardiac arrest is through the ambulance services. And they record every cardiac arrest they've attended where CPR has been given, for example, and we receive all of that data. But then we adjudicate or compare that data against either the hospital data or the autopsy data for people who've had one. And that's really important that we do that, because we know from studies elsewhere in the world that if you don't actually look at the autopsy results, about 40% of what the ambulance has called a cardiac arrest is not. It's diabetes or a stroke or something else. And so if we didn't do that, there'd be a real risk that a lot of patients or their families would be walking around thinking they've got this terrible heart history in the family. And firstly, they may not, but also there might be something else really important that needs investigating. So we do a lot of sorting through and comparing investigations, and then sort of providing a diagnosis to the family from that point.
Robert has just asked a question about analysis of the blood. What can you take from analysing the blood of somebody who's had cardiac arrest or heart failure or something along those lines?
So if the person is alive and say in hospital, there are a lot of tests we can do. And they may, for instance, tell us if the person's had a heart attack. There's certain proteins we look at, or whether they've got other abnormalities that could suggest alternative causes. If the person has died, it's really challenging, and there's not a lot of evidence for how you measure even something as simple as a cholesterol level in a person who's passed away. And so this is one of our sub-projects in the registry, is to try and even just build that evidence base for how a simple blood test might be able to answer some questions and avoid perhaps a full autopsy in the future for families.
Yeah, I see one of the challenges that the Baker Institute faces overall in terms of getting the funding for research is being able to tell the story, because as you've just identified, sometimes you just get to complain about the bad food, or you have heart failure and you pass away. Whereas many of the other diseases, you can see the disease, but cardiovascular related issues, it's either you're alive or you're dead. And this part of being able to tell that story, I think, is going to be important to generate the funds to get the ability to do more research. So the research that you're doing is really significant in being able to find some answers to that unexplained death, and then maybe find some solutions.
Yes, yeah. And I think, any problem that's got a 90%, let's say, death rate or a fail rate in terms of outcomes, there is huge scope for improving people's outcomes, clearly. This is not trying to make 1% improvements, but even if we did, that would deliver enormous changes for families around Australia.
Yeah, Chris has asked a question, and this is a syndrome that I have no knowledge of at all. And he's interested in seeing whether there's been any research done on the relationship between Brugada syndrome and sudden cardiac death.
Yeah, so absolutely. We collect in our registry if someone's had a sudden cardiac arrest due to Brugada syndrome, they are included.
What is Brugada syndrome?
Yeah, so for the audience in general, Brugada syndrome is an arrhythmia, an arrhythmic syndrome, usually quite genetic, and typically affecting males more than females, and it is associated with sudden cardiac death. And so If that's identified as being the likely cause of death, all the family, first-degree family members, so parents, siblings, children, should always all be offered family screening.
Okay.
To check their risk.
Yeah, yeah. We had a question earlier from Lisa about defibrillators and the impact that they can have on survival rates.
Yeah. So defibrillators are one of the really well-supported pieces of evidence that they can save lives. And they are probably the single most effective thing if someone has a cardiac arrest near you. The big issue we face in terms of defibrillators is firstly accessibility. So people won't, unfortunately, always have a cardiac arrest right next to a defibrillator. So it's said that the best places to have it, if you're planning your cardiac arrest, it should be either the MCG or Crown Casino would be your best bets in terms of.
I'll keep that in mind, Liz. Yeah.
The other issue, though, is even if you do have one, you're standing right next to the defibrillator, you need someone who's confident to take it off the wall and put it on you while they're waiting for the paramedics, because every second counts. And so having people be confident to do that is the other really important thing. And probably everyone who's dialed into today is extremely motivated and has done a CPR course and would be confident. But I can't emphasize enough that it's so important to do a CPR course, get your hands on a defibrillator and a try. And if you're ever in the situation, you can't go wrong when there's a 90% bad outcome rate. You can only add benefit. Yeah. And there is absolutely no downside to attempting CPR and putting a defibrillator on.
Well, I'm sure that a friend of mine, Bruce, won't mind me telling this story. He had a heart attack in bed at, sort of 11:30 at night. And he's got 3 sort of young adult children, sort of in their late teens, early 20s. And his wife, when they first had kids, they were getting into junior sport. And as part of that, she had to do a CPR course, and she'd never used it. And she dragged Bruce off the bed, started doing CPR as she was getting her one son that's still living at home, calling 000. And that's the difference between Bruce being with us today or not being with us. And Bruce is really fit. He rides a bike a lot.
And it sounds like it's also a difference between him being really good as opposed to having a disability, the fact she was so prompt as well, which is so important.
And she just went into survival mode. She really, and she did the panic afterwards, which is an incredible story. So, he was indebted to her beforehand. Now he's really indebted to her. Yeah. So in terms of your work, the project that you're working on at the moment, the PhD that you're doing around unexplained cardiac death, what are you hoping to achieve through that?
So there are several things through the PhD, which I think is a really clinically important project, much more than just kind of the PhD itself. So as you mentioned, this is the first registry of its kind in Australia that sort of samples from so many data sources and provides comprehensive information to the families, but also to people like government and research, and puts a number on how big the problem is. We offer as well clinics with free family screening for all the family members who might be at risk. And what we know from international data is that where they've had similar things set up, in France, for example, about 4% of family members will get screening done in the year after a relative's cardiac arrest, but 30% of them might be at risk of the same condition. So there's a big disconnect between those numbers. So we need to identify other family members who are at risk and modify their risk before a family suffers a second tragedy. Is really important.
Yeah, well, we've just had a question come in from Tracy, which is a tough question as well. And she's had a SCA, sudden cardiac arrest, and she's a survivor of that. Sadly, her brother had a sudden cardiac death at the age of 39. She's done genetic testing that revealed no really genetic condition for her, but a gene VUS is common that is not the known cause. She had underlying issues with VT. Yeah.
So to sort of paraphrase that a bit and maybe just add some background information, a certain proportion of sudden cardiac arrests will remain unexplained even after top-level investigations like genetic testing. And it's probably in the order of about 30% of cases, even after they've had an autopsy and genetic testing, we still don't have a clear answer. And a VUS is what we call a variant of unknown significance, which means it's a gene that has been sometimes associated with some abnormalities, but we can't comprehensively tell you that's the reason you've definitely had this event. And so Tracy's question ties really well into the importance of our research, which is that we can't explain everything at this time point, but we do also build a genetic biobank and take a blood sample from consenting survivors and the family of the deceased. And with building that, we provide a resource that as we keep making genetic discoveries and chipping away at that 30% that are unexplained, we offer families the opportunity to reanalyze and genes get upgraded or downgraded from that VUS unknown significant status to being definitely the problem, or we've discovered that actually that's probably not the reason, but we found this other new gene that we'd like to relook at for you. So we hopefully can provide ongoing answers to families and either reassure them of their risk or manage it for them.
Yeah, and I also imagine a lot of families would find that as a positive outcome from a tragedy in that you're making a contribution. I know in my family, beyond the cardiac issue, my 2 aunties and my mum have all had breast cancer, and my sister has had breast cancer. 2 of my aunties died as a result of it, but because they died as a result of it, now the earlier screening, the younger auntie and my sister, early screening, and they've managed to survive it. And I've had 4 sisters, and they've all been part of a study of, what's the gene that causes this. And they actually find that reassuring in that, their mum, my mum and our auntie, it hasn't been in vain, their early passing.
I think you're exactly right. It can sort of feel like you're sort of, gaining some meaning. And also there's an enormous, perhaps enthusiasm is not the right word, but desire to contribute to research amongst the cardiac arrest community because it's such a dramatic event. People generally are very keen in any way to contribute to ongoing research and findings.
Yeah, there was another question that followed up a little bit earlier from that one, and this comes from Andrew, and it was, how many unexplained cardiac death at age 50 and under have a pre-existing diagnosed arrhythmia?
So the short answer is very few, which can be interpreted several ways. If you want to be optimistic, could say it probably means people with arrhythmias or cardiac problems who are young are being well looked after if they're not having cardiac arrests. But our research, and we're hoping to sort of write this up once we have a slightly bigger cohort next year, suggests that only 1 in 6 of our young under 50 cardiac arrest patients had any symptoms or had seen a cardiologist before the arrest, which obviously is a really low number. And there's probably a few reasons for that, including that young people are less likely to see a doctor than maybe a 70-year-old who has any symptom and might be a bit more alert to things. But yeah, I would say from our data, we would say sort of a maximum of 1 in 6, but that 1 in 6 figure includes people who don't even have arrhythmias. They've got other issues like they've had stents or something or had a coronary artery blockage. So probably more like about 10% of patients would be the answer to that question.
Okay, well, Alistair sent in a question earlier on as well, which kind of follows on from that also. If you have a family history of heart disease, what tests can be done to show what future risks there are for you? And is calcium test worthwhile? And how do you get one done?
Okay, that's quite a segmented question. So to start with if you have a family history part of it, certainly if you have a family history, I think it's worth seeing a doctor and perhaps a cardiologist to discuss that further. And the first step is to be really clear about what that family history is, because of course, that's a really vague term. And, if your grandma at 84 had a heart attack, that's very different to your sister at 30 needing a heart transplant. So it's really important. And at our clinics, we draw a proper family tree over 3 generations, chase all the investigations, and are really clear about what definite diagnoses have occurred. And then depending on what the diagnoses are in the family, if there's a really clear pattern of something like heart attacks at a very young age, that kind of directs which tests would be most appropriate for you. And depending on the diagnoses, there may be different tests that you get recommended to have. Now, coronary artery calcium score is one of the tests that sometimes people are recommended to have. It's a relatively new test, and there's sort of a lot of increasing interest and enthusiasm for it. And essentially what it does, it's like a very quick CAT scan. It takes probably about 5 seconds. And you go in a CAT scanner and they just look at how much calcium is in your coronary arteries. And that's a marker of if you've got plaque or sort of cholesterol buildup there. I guess things to mention on it though are that it's got excellent evidence that it can reclassify your cardiac risk beyond those traditional risk factors like diabetes, smoking, etc. But you should be in the right age group to have it done. And so all the trials were aged 45 to 70. So if you're 90, we would expect that you have built up some calcium in your coronary arteries by that point. It's not going to inform us if we do a calcium score and find calcium that you're necessarily at higher risk. If you're super young as well and you're 20, you can have severe heart disease without any calcium buildup because it just hasn't been there long enough, but it could be severe. And we actually undertook a project on this that showed that about 30% of people dying from heart attacks at a young age, so in their 30s and even early 40s, had calcium scores of 0. So they would have been reassured, but the test would not have been the right test for them because they were too young. So it's really important to make sure you sort of get it done within those indications of being about age 50 to 70. And ideally, you should be someone who's got one or so risk factors for heart disease, and you just want to get a bit more information about whether you're particularly high risk or whether you could be reassured you're maybe lower risk than you would generally think. And just to answer that final question on how do I get one, they're done at almost all radiology providers, but just so that anyone who's going to go order one after this knows, they're not actually subsidised at all yet. So it's usually about $100 to $150 out of pocket to have them done from the radiologist.
Okay, is there, if you are diagnosed or your family has that medical history, as my family does as well, my mum was always adamant that we got regular cholesterol checks and wanted to make sure that our cholesterol was good. And we've always been really active, our entire family. There's also that fear of some people of being, paralysis with too much information and afraid of doing anything. Pip Hauser has asked the question about, the risk of doing too much exercise. So I have tachycardia occasionally, my heart goes out of rhythm and so on, but I'm not going to stop riding my bike and I'm not going to stop playing tennis and chasing my kids around the park and so on. So there's that balance in the lifestyle choices as well, staying fit and active.
Yeah, and so obviously I'm in the sports cardiology laboratory, so we'll tend to err on the side of recommending exercise. But I think firstly that everybody is their own best doctor in the sense that they'll know if symptoms are emerging or changing, and that shouldn't be ignored. But at the same time, that should prompt further investigations and follow up. But exercise is really good for several reasons. One is that it keeps your heart fit and better able to withstand injuries and other illnesses. But the other thing is that somebody who's going out and cycling, say 20 kilometres a week, is probably going to notice symptoms earlier than the person who sits on the couch all day because they're not working their heart hard enough to notice that they're not getting enough oxygen. And so being a regular exerciser also is regularly stress testing yourself essentially so that you hopefully get a head start on any problems and recognising them. And so if you notice something's gone off dramatically, that's really important, not to just stop exercise, but maybe to pull back and get it investigated so you can return to your best as soon as possible.
And as my wife tells me, whenever I'm getting a little bit grumpy around the house, her recommendation as the doctor of the house is to go for a bike ride.
Right, yeah.
So I'm always in a better mood after I've done some exercise, without question. And then also, what about diet choices? We had a question that came in from somebody asking about the impact of diet choices on cardiac disease and so on.
So generally, in terms of sort of, I'm not particularly strict as a cardiologist, I have to say. And my general recommendation would be to try and exercise regularly and maintain a healthy weight and to make, sort of the CSIRO diet type healthy choices and have a balanced diet. But in terms of any particular diets, there's some evidence that maybe a more Mediterranean diet with sort of the natural fats can be helpful for the heart. But the most important thing, I think, is just being a healthy weight and exercising regularly and sort of feeling happy and confident and enjoying your food.
Asking for a friend, red wine?
Yeah, so probably good in moderation and not in excess.
Okay.
Yeah, but certainly allowed in moderation.
Excellent. I'm happy with that answer. And I like the Mediterranean diet from a flavour perspective anyway. Yvette has asked a question, and this is another one that I know absolutely nothing about. Has factor V Leiden been considered, as her family has a history of sudden cardiac death from a young age, plus I've had blood clots and have factor V. So firstly, what is factor V Leiden? And then the rest of that question and its impact.
So factor V Leiden is a molecule that's involved, or particle that's involved in blood clotting. It regulates the response. If you're deficient in it, you may be more prone to clotting. And so it certainly can be associated with blood clots in the lungs, the legs, etc., and also with blood clots in arteries like the coronary arteries. In terms of the question of whether, I think Yvette is sort of asking, would we routinely test for that at a post-mortem examination? It's not something that would be tested for in every case of sudden cardiac death due to, firstly, I guess, the non-specificity of it. There's a lot of people who have that mutation and that deficiency and don't have a sudden cardiac death. But the other thing is it would depend on the clinical scenario. So if someone died very suddenly and then lots and lots of blood clots were found in their arteries or veins at the post-mortem, that would probably raise the pathologist's suspicion. And then they would send off for genetic testing and initiate that trail, and also recommend that the family gets screened.
Yeah, that's data gathering and so on. And the project that you're working on now is about that data gathering. And Robert has asked a really good question here about, are you able to easily get the data that you need to build the database, or do you get separate information gathering from all different channels, and it's a real challenge to try and pull it all together?
So probably I would say yes to both halves of those questions. So the front end of our registry is sort of the ambulance. And so we receive all the information of everyone who's had a cardiac arrest. And then we add to those files and those datas from chasing information from all the other places, whether they've been to a hospital or to a forensic institute. And of course, the consent of the families is involved along the way as well. So it's certainly a laborious process to pull all of that information together. But as I sort of mentioned earlier, we've had overwhelming desire to be involved from the families in general. And the numbers, unfortunately, are really high. So in terms of getting a really comprehensive registry and getting everything together, we certainly, unfortunately, have not struggled from that end. And so we have over 1,000 patients in our registry currently who are under 50 who've had a cardiac arrest since 2019.
There was the pilot who passed away a few years ago of a sudden cardiac arrest, and there's been a foundation connected with the Baker Institute. His name has just escaped me. So
Captain Ross Dennerstein.
That's it. Yeah. So what's the relationship between the work that you're doing and the work that the Dennerstein Foundation's doing?
They're very directly related. And it's probably wonderful that you've brought him up. And so he was 47 and a father of 2. And obviously had medicals done as a pilot over the years, which he had passed, and had a sudden cardiac arrest, which he died from, and which remained unexplained even after very thorough investigations. And so I guess the next step was that his mum is a very prominent Melbourne doctor, and, you know, sort of after this personal experience, but also hearing the extent of the problem, was very dynamic in creating a foundation in his memory and raising funds, which has really been what's underpinned the creation of our registry. So it's really a direct descendant of that foundation and very intimately linked to it.
Yeah, I've met his mum, and I just want 10% of her energy. She's an amazing woman.
Yes.
Yeah. We've got a question here from Romain, I think it is. What causes irregular heart rhythm?
So that's a very broad question, and the answer is a lot of things. And there are lots of different types of irregular heart rhythms as well. So some are very non-troublesome and some are very concerning.
Okay. Yeah. And are there any studies, this is a question from Irene, any studies on heart attacks where high cholesterol is the only risk factor?
So in a sense, yes. And there is a genetic condition called familial hyperlipidemia where you have very high cholesterol despite your diet, and you usually require medication to control it. And so that often manifests in young people having heart attacks or blockages of the coronary arteries. And then we identify that they've got very high cholesterol and that's their only risk factor. And it's estimated that probably about 50% of families with familial hyperlipidemia are still undiagnosed. So that kind of underscores the importance of, I mean, you mentioned you're very aware of your cholesterol, but people in general may be having at least a one-off cholesterol test if they're young. And if they're over 50, having a regular idea of their cholesterol and that it's well controlled.
Yeah, my father-in-law's cholesterol is through the roof and he's not doing enough to bring it down. He constantly gets in trouble from my wife. There's a good question from Joe, and I'm really interested in the answer of this. Do you have any ideas as to why sudden cardiac death is more common in males than it is in females?
It's a really good question. And the short answer is no.
Okay.
It's a consistent, just a really sort of...
Hence your research.
Yeah, but it's a really consistent pattern around the world. That it's more common in males than females. And in some genetic syndromes, they predominantly affect males due to the inheritance patterns, but it's not enough to explain the overall prevalence of sudden cardiac death affecting males more than females.
Okay.
One comment I'll make on the gender things, though, is that some countries, such as America, have shown that women have less cardiac arrest, but they have worse outcomes. We haven't seen that in our research to date, and that's very reassuring. In Victoria, men and women have the same outcomes once they've had the cardiac arrest. So that's a very nice thing to see.
All right, here's a really good question from Jeff, which goes directly to the work that you're doing now. Can you tell us more about the registry and what is stored on it? And will it be available to the public?
So in terms of the registry, it's housed at the Baker, of course, sort of very securely. And what's stored on it is predominantly the clinical information of the people who've had a cardiac arrest who are happy to have that stored, the results of their tests, and then if the families are keen to be screened and consent to inclusion, also their results. And then we also have the genetic biobank physically stored at the Baker as well, with blood samples there for future analysis. In terms of the results, we are hoping next year, when the registry's been going for 2 years, so that's when we'll really present a lot of our data. But of course, it's all presented very much in aggregate de-identified form. Nobody's name is ever going to appear out of it. It's just going to be overall numbers and percentages to quantify the impact of cardiac arrest.
The question from Marion and Barry, which goes back to the male-female thing, and are the symptoms of pre-heart attack different or the same are those between males and females?
Yes, so that's a really interesting question, and it's one that's certainly received, I think, a bit of attention in the media. And there is concern that women particularly can have what we call atypical symptoms. So rather than having the things we might hear about in the TV ads like crushing chest pain, going up to the jaw, shortness of breath, feeling sick, they might have more just the feeling sick, or some arm pain rather than chest pain. The other thing I would just comment as well, both clinically and from the registry work, is the other symptom that sometimes gets mistaken for chest pain. People may think they have reflux, but it's really bad reflux, and they have never really had reflux before and it's not going away. And it's really disheartening, the number of people who've had a sudden cardiac death and the post-mortem report comments that, you know, there's a bottle of Gaviscon by the bed, or the family, they never had a cardiac symptom, but they complained of really bad reflux the day before. So if any symptom that's really serious and concerning and new, and you feel really unwell with it, you should always, I think, get it checked out ASAP, and sometimes at emergency if needed.
Yeah, there's been a lot of talk, particularly with the cancers, of people not going to get checked up throughout the COVID pandemic. Have you seen any of that in terms of cardiac disease?
We have, unfortunately. I think less in the second lockdown than the first. People were very hesitant. We reached an all-time low of 2 inpatients at one point during the first lockdown in Melbourne. And the emergency department certainly was just empty apart from COVID patients. So now I think things are settling a bit, in cardiology at least. We have people very keen to resume their regular testing, face-to-face appointments, and certainly our inpatient lists are very full again. So I think we're all hopefully returning to a bit of normality in general.
Yeah. There's a sad question here from Robert. His daughter passed away of no apparent cause at 28 years of age. Nothing identified in the autopsy or generic testing, but his wife has atrial fibrillation. Could there be any sort of connection there?
Yeah, so that's one of those ones where it's so difficult to comment on because, you know, there's no clear diagnosis. And so that's sort of the exact kind of patients we're really keen to evaluate further, and also to have the genetic testing for the biobank, so that as we become more aware of genes involved in AF and heart failures, we can provide more definite answers as to whether Robert's daughter might have had, a gene that was linked with a particularly adverse outcome or may have had arrhythmias and things.
Yeah, really sorry to hear that, Robert. One final question here from Jessica about, is it always possible for a GP to actually be able to detect, or a hospital to be able to detect, if a cardiac arrest or something along those lines is about to happen? I'm suggesting that based on what you've told us today, it's not.
No, unfortunately it's not. So sometimes, people will have those horror stories where they've gotten checked out and been reassured, and then a week later something terrible has happened. So not always possible to predict them all. And so all we can do from our end, I think, is be vigilant for any symptoms, be really proactive with our health, and take advantage of all the testing that we have currently in 2020 to be proactive about things, but knowing that maybe in 2030, there'll be newer, better tests available. And at that point, it will be more easy to predict who's at risk.
Yeah, and Yvette has asked the question, the registry that you're putting together, is that going to be shared worldwide, or will it be Australia only?
So currently, in terms of the data collection, it's Victoria only, but hopefully extending to New South Wales and Tasmania soon, and then ultimately hoping to be national. But we've deliberately designed it so that it's very comparable to the few other registries worldwide, particularly in France and Seattle and the UK, so that data can then be collaborated and shared, and we can sort of really compare our findings internationally and both benchmark but also lead in some ways.
Yeah, and then before we do let you go, what does your average day look like? And what is a woohoo moment for somebody doing research at the Baker?
So my average day, I think, is really variable, but ideally, there's a mix of patient engagement and hopefully face-to-face, which at the moment I've been doing a lot of telehealth and really miss taking a blood pressure. So combined with, data sheets and statistics, and there's also, I guess, the lab side as well, and actually working on our samples and analysis. In terms of a woohoo moment, I guess really it's just ultimately about helping the families in the registry. So sometimes it might be sort of, a pattern or a paper coming together with a new finding. But really, if we can just answer a question for a family or provide them with closure or set them up with a resource that wasn't immediately available, that's one of the most rewarding parts of the whole registry.
Well, when's the PhD finish?
The plan is the end of next year, but I'll be involved in the registry indefinitely ongoing.
Fantastic. It's really important work. We thank you for your time today. We thank everybody for sending in the questions. Unfortunately, we weren't able to quite get to all of them, but we've enjoyed seeing your questions come through. And I'm guessing that you'll be heading back into the Baker shortly to be able to work. You've been juggling between going into the Baker and working from home throughout the lockdown period.
Yes, yeah, essentially, yep.
Fantastic. Yep. Well, thanks everybody for joining us, and particularly thanks to Bank of Melbourne. Without their support, it wouldn't be possible. Without your support of the Baker, people like Liz and her team at the Baker Institute wouldn't be able to do the crucial research work that they do. And this one is really important, and judged by the questions that we've seen come in throughout this webinar, it's important to you as well. We're really keen to get your feedback. A survey will be sent out via email. So we'd love to hear your thoughts on this webinar and how we can improve them and what sort of topics you'd like to hear in the future as well. Thanks everybody once again for joining us, particularly to you, Liz. Stay safe, and we'll see you again next time.